Hello students, we are going to start our practicals according to the guidelines of university. Now we are going to start our practical paper number 12, section physical chemistry, experiment number 1. Title of the experiment is Conductometric Titration. Aim: to determine the normality and strength of given HCl solution using 0.1 normal NaOH solution conductometrically. So according to this aim, we have to determine the normality and strength of strong acid HCl by titrating with NaOH solution. Now the concept of this practical is, this titration can be performed by measuring electrical conductivity, and from that we can determine the end point or neutralization point. Electrical conductivity is the capacity of ions in a solution to carry the electric current. Now we will see the theory of this experiment. Initially, the solution, that is HCl, shows high conductance value because HCl is a strong acid which completely dissociates. The conductance of solution depends upon the concentration and mobility of ions. When HCl is titrated with NaOH, highly mobile H plus ions are replaced by less mobile Na plus ions, and therefore the conductance of solution decreases till complete neutralization of HCl, that is up to the end point. After end point or neutralization point, the conductance of solution increases with further addition of NaOH solution. This increase is due to the fast moving free OH ions from NaOH. Thus, when we plot the graph, conductance versus volume of NaOH solution, two straight lines will obtained which intersect, and this intersect of these two lines is the end point of titration. Now we will see the apparatus: conductometer, beaker, magnetic stirrer, burette and pipette. The chemicals required: given HCl solution, we don't know the normality of this HCl solution, that only we have to determine. And the other solution is 0.1 normal NaOH solution. Reaction is HCl plus NaOH. There is a formation of NaCl plus water. Now we will see the procedure of this experiment. First, rinse and fill the burette with 0.1 normal NaOH solution and adjust the zero mark. Now pipette out 5 ml of given HCl solution in 100 ml glass beaker and add to it 45 ml distilled water. Place the magnetic stirrer into the beaker. Now the next step is, dip the conductivity cell or electrode into this solution and connect it to the conductometer. Shake the solution with magnetic stirrer and note down the observed conductance. If the magnetic stirrer is not available, then shake the solution by hand. Now add 0.5 ml NaOH solution from the burette, and every time after addition, stir the solution well and note down the conductance. Continue the titration till the conductance increases sharply up to the total 10 ml of NaOH added into the solution. Now the last step is plot a graph of conductance against volume of NaOH added. Now we will see the observations. Solution in burette is 0.1 normal NaOH solution. Solution in beaker as 5 ml HCl plus 45 ml distilled water. Plot a graph of volume of NaOH added against observed conductance. The point of the intersection of two lines gives end point. Now you can observe this graph. On x-axis there is a volume of NaOH added. Here it is not mentioned but you have to write it. On y-axis there is a conductivity. When we observe this graph, we get two lines which intersects with each other, V-shaped graph. Initially, it is found that the conductance value is very high due to the strong acid HCl. As the addition of NaOH takes place, the conductance value goes on decreasing due to the replacement of H plus ions by slow moving Na plus ions. After neutralization point, the conductance increases sharply due to the fast moving OH ions added into the solution. Thus, the intersection of these two lines gives the end point and we get here the volume of NaOH at this point and it is as the end point volume, that is V2. Now the calculations are, the titration is HCl versus NaOH. We have to determine normality of HCl. So N1 V1 is equal to N2 V2. N1 as it is, that we have to determine, into volume of HCl is taken as 5 ml is equal to normality of NaOH is 0.1 and the V2 is the end point which we get from the graph. Now put this value and calculate the normality. N1 as equal to 0.1 into V2 upon 5. If the experiment performed accurately, then this end point generally, which we take the amount of HCl, it will be same, that is V2 is equal to 5. Then the normality will get as N1 is equal to 0.1. Now calculate the strength of HCl as normality into equivalent weight of HCl. So put the value of normality, multiply it with equivalent weight of HCl, it is 36.5. Then we will get as strength of HCl in grams per liter. Result, normality of HCl we have to mention in normal. Strength of HCl we have to mention the amount in grams per liter. The conclusion of this experiment is, we can determine accurately the normality and strength of strong acid HCl by this conductometric titration. The significance of this experiment is, indicator is not required for this titration, and end point is detected graphically, hence it is accurate. We can also perform the titrations for turbid and colored solutions, and we can analyze it. I have attached the video of this practical. You can watch it and understand well.
Students, today we will see the practical acid-base titration by conductometric measurement. Now you can observe here, this is the conductometer, then here is a beaker. In this beaker there is 5 ml acid solution, and in burette, this is burette, it is filled with the alkali solution, that is 0.1 normal NaOH solution, and the conductometric cell is dipped into this solution. In beaker there is a 5 ml HCl solution plus 45 ml distilled water. Now this is the setup for the experiment of conductometric titration. Now we'll start the readings. Here, without addition of NaOH, that is without addition of NaOH, that is 0 ml reading that we have to note down first. Here it shows as 1.79. Now add 0.5 ml NaOH solution from this burette. I'll add this 0.5 solution. Now shake the solution well. And note down the conductance. This is the conductance value. Now we observe here the conductance value changes by addition of NaOH solution. Thus we have to add 0.5 ml NaOH, and after every addition of NaOH we have to note down the conductance value. Thus we have to perform the practical up to the completion of 10 ml NaOH solution.
Thank you. Thank you very much.